My name is Thea Sommerschield. I am a doctoral student at the University of Oxford, currently finishing my PhD.
And what is your PhD focused in?
Oh, my PhD focuses on something completely different from all of this. My PhD looks at how the indigenous and migrant communities settled in Western Sicily in the Archaic and Classical period negotiated their sociocultural identities. And one of the big data sets which I'm using to trace these identities, one is burial evidence, and the other data set is ancient inscriptions, which are texts written on a durable surface, so stone or pottery, which have been preserved over the millennia to our day.
So you said the word data set almost casually in my world, that, oh yes, we have this data set in the same way I can go to download a data set in a CSV file off a website. I suspect your work wasn't quite so easy. What's the nature of your data set and how you get your hands on it?
For my thesis, which is a different project from Pythia, though it was the starting blocks because I work on a so-called epigraphical data set, so inscriptions, as I was saying before. They also happen to be one of the main sources of new evidence concerning the ancient world. About 50 new inscriptions from Attica, for instance, where Athens is and was, are discovered and published every year. So with dataset, I mean all of the published inscriptions, or even in some cases, some unpublished ones from this region in this period. And as far as the archaeological, so the burial data is concerned, this is also working on published and unpublished materials, so doing a little bit of archival research, and especially the most fun part, going to Sicily and visiting the sites myself.
I think it's fair to say that you and your collaborators form a pretty interdisciplinary team. How does a project like this come together?
I attended the same college in Oxford as Yanis Asael, who is my co-author. My other co-author is Jonathan Prague, who is a professor at the University of Oxford in ancient history as well. Because I was interested in the written cultures of the ancient world and in the emerging field of digital humanities, which is probably the reason why I referred to what you could call corpora or assemblages of evidence as data sets. Mm-hmm. We started working together on using machine learning to make tools to aid and extend the scope of an ancient historian's work. And because of my prior interest in inscriptions, we started off with actually an incredibly topical problem, which is the reconstruction, the so-called restoration of ancient Greek texts, which are written on stone. So these texts are called inscriptions. Inscriptions are special among all of the possible data from the ancient world to me because they are a body of evidence which has survived directly from antiquity to our time. It's first-hand evidence. This is a text which somebody physically inscribed 2,500 years ago. So there's nothing quite like the directness of an epigraphic text. Because of my personal interest, we decided to tackle this topic specifically.
What is an epigraphist?
An epigraphist is a discipline that studies ancient Greek inscriptions, which can be in any language from Latin to Punic to Greek, for instance, but also Sanskrit, etc., to move beyond the realm of the ancient Mediterranean. The discipline of epigraphy must study these inscriptions. And one of the main tasks of an epigraphist is to restore missing parts of these texts. As you can imagine, the reason why human beings all that time ago decided to inscribe texts on rock and stone was because stone guarantees immortality. They knew that this message, whatever it was, be it a decree, be it a law. I worked on texts inscribed on lead, which are curse tablets from Sicily. Imagine that. What they wanted to achieve was the immortality of the written word. However, after 2,500 years, even the most sturdy piece of stone will have suffered some damage. And so one of the main tasks of epigraphy is to restore the missing text. It is a complex and time-consuming task. It involves knowing at least a little about almost everything. However, restored inscriptions can teach us about almost every aspect of the ancient social, religious, political, economic life of the ancient world. So it's incredibly valuable information.
your point about this being firsthand and what those people actually wrote makes it valuable no matter what the contents. But I'm curious, do you know something about the contents? Is it, laws of the time, or could it be something more mundane like a laundry list or something like that?
It could be literally everything. So for my thesis, for instance, I'm working on, like I said, curse tablets. So texts written I'm looking at ancient Greek texts written between 550 BC to 100 AD. They literally curse people. They write down the lists of the names of the people that they want to curse, and then they write something like, may his tongue be tied or registered. And they can get pretty nasty. And other case studies that my thesis looks at are votive inscriptions, which are texts inscribed on some stone blocks in a special open-air sanctuary, which was in use in the Phoenician settlements in the central Mediterranean, where in some pottery urns, archaeologists have found the burnt remains of infants and animals. And the inscriptions, which are sort of the markers of these urns, register texts such as to Baal Hamon, this is the offering. It's often interpreted as offering, but nobody really knows the meaning of that particular word, by so-and-so. So it's very, very varied. It can be ancient laws, it can be votive offerings, it can be curse tablets, or it can be on other types of supports. So for instance, papyrology, which studies ancient papyri, it could be an ancient Greek tragedy, or it could be literally a shopping list or a letter. The variability is immense.
I'm curious, could a modern speaker of those languages, I guess maybe Greek in particular, would they be able to read and understand this? Or, I don't know, is it in some way different where they can't, a modern person wouldn't be able to get to read it directly?
You would need specialized knowledge in ancient Greek, in Latin, in Phoenician. Perhaps people are more familiar with Latin. It's as if you asked a French person to make perfect sense, or an Italian person. I am Italian, so this can work for me. An Italian person who has no prior knowledge of Latin to just look at a Latin inscription and make sense of it. Despite Latin being the sort of the source language from which Romance languages such as French and Italian have come down from, there is still a huge variability in contents, in context, in grammatical and linguistic structures, which has similarities with today's modern languages, but it is a different language in of itself. Furthermore, when you are dealing with these texts, to get, for example, back to the curse tablets are texts inscribed on a piece of lead which has been rolled out. It is the average size of a business card, which then the person who has written this cursing text rolls up and throws into a tomb, generally. That is the practice. So if you are trying to read that text, first of all, it is an immense restoration issue because you have to physically unroll a piece of lead, poisonous lead, which has been lying in the bottom of a tomb for 2,500 years. And secondly, the text itself is badly preserved because it's probably been scratched in with a stylus or some kind of sharp object. You're not only dealing with a language which you might not know and that you have to be an expert to start getting at, but even for the expert, it's going to be incredibly demanding, incredibly complex and time consuming. And this is specifically one of the aspects, which is the restoration of what text went missing, what we cannot read anymore. That is precisely what our project set out to offer an assistive tool for.
I'm curious about that restoration project. When a word is missing because the medium was damaged, I suppose sometimes it's obvious, you can fill it in, but other times maybe you have a good guess. How much, opinion or non-determinism goes into this step?
To tell you about that, I think first I should tell you a little bit about the architecture. To put it very, very simply, our architecture works at both a character and a word level. This is because we wanted to encode word information alongside the character information because we wanted to handle context more efficiently. However, we couldn't only use words because most of the words of our dataset are incomplete or damaged, so we had to include the character information in the architecture as well. For this reason, our model works both at a character and a word level, and therefore it can effectively handle long-term context information and deal efficiently with incomplete word representations. Currently, Text restoration is approached by epigraphists, who are the specialists which we were referring to earlier, by accessing vast repositories of information which provide textual and contextual parallels. Restorations are also guided by linguistic, grammatical considerations, as well as shape and layout. If you're dealing with a slab of Parian marble, which you have found on the Acropolis of Athens, and you can see that half of it is missing, but you can still detect the rectangular shape beneath it, then you can start making guesses of how many characters are missing based on the layout of the other characters. In Athens, during the classical period, it was very fashionable to write text in a kind of a grid formation. This is super helpful for epigraphists because the characters are in a grid where you can make out how many letters are missing with a varying degree of accuracy. But there are some cases in which the inscription has just been cut in half or has been used as a doormat of an ancient church for hundreds of years, and that text has just been rubbed out by people walking on it. And this is true story. Loads of inscriptions, because the monumental ones especially are written on big, big blocks of nice quality stone. These stones are often picked up by people maybe in the medieval age, it's already 1,000 years afterwards, and used to build the foundations of their houses. It's not uncommon if you go to certain archaeological sites in Greece or Italy to walk past maybe a very ancient church, and then you double tick because there's an inscription embedded in the wall. This happened to a friend of mine, actually. To get back to the text restoration task, epigraphists can either rely on their mnemonic repertoire of textual and contextual parallels, use printed corpora and indexes, and in recent years, there has been an increasing availability of digital corpora for performing searches that match word patterns, so string matching searches, which, however, as you can imagine, can be inefficient because they assume that the context information can only be captured by pairing characters instead of finding patterns in this data.
Thanks to this week's sponsor, GiveWell. GiveWell identifies the charities that save or improve lives the most per dollar. You can have a massive impact. Treat intestinal parasites for less than $1, or save a life for a few $1,000s. GiveWell does extensive research to find the ways to maximize the effectiveness of your donation. One of the impactful programs that they recommend is the distribution of deworming treatment. These treatments kill intestinal parasites. While that may not affect you personally, the CDC estimates that up to 1 billion people have these parasites. And multiple meta-analyses have found that deworming treatments effectively kill the intestinal parasites. And thanks to GiveWell, I know that multiple meta-analyses have found that these deworming treatments are effective in killing the intestinal parasites. GiveWell then finds the charities that are most effective in getting those treatments out to the people who need them. Learn about their methods, research, and most importantly, their recommendations by visiting givewell.org/dataskeptic. New donors get their donation matched up to $1,000 by visiting givewell.org/dataskeptic. During your explanation, you hit on a key word we've been discussing a lot in our NLP episodes, and that's context, which maybe from your point of view, the way you said it's kind of obvious. Of course you need the context, but computer science and machine learning people have been figuring this out in the last couple of years. Maybe can you describe your understanding of that word and how you came to perceive the way machine learning people talk about it?
So we realized pretty early on that we didn't realize pretty early on. We came to realize after a lot of work by visualizing the attention weights for Pythia's restorations that there was something going on. And I went through about hundreds of TXT files just visualizing the Pythia's attentions, and we came across finally some cases in which a personal name, the Greek personal name Apollodorus actually, appeared twice in the text. What we did was we hid the first 9 characters of this name, and we asked Pythia to predict the first 9 characters, and we visualized the attention weights for the decoding of these missing characters. What we could see was that Pythia was dedicating attention to the relevant parts of the text. It correctly gave us a prediction hypothesis, the name Apollodorus, which is what we wanted it to do. And then, because this was an example that was just too good to throw away, was just after one use, we decided to manipulate the inscription so that we changed the personal name from Apollodorus to Artemidorus, which is similar length name, another Greek personal name. And we substituted the two name occurrences with this new name, and then we hid the first characters again, the first 9 characters of the second occurrence of the name, and said, Pythia, okay, do it, restore it. Pythia's prediction correctly altered to Artemidorus, and again, the attention weight attended at each decoding step to the name's first occurrence in the text. We then did some other evaluations, and we found out that context does matter, and especially the more text there is, the better is the performance. And we managed to evaluate this with a graph, which I think is on the published paper, and you can see very clearly there that the performance flattens out at around 500 characters. So context does matter, and by visualizing Pythia's attention, we can also see what parts of the text input affect the predictions of each output.
I'd love to talk a little bit about the training process, maybe starting from the training data set and then some of the methodology. How did you go about building Pythia?
First of all, we needed data. So we set about, where can I find thousands of digitized Greek text? And those digital corpora, which I mentioned before as one of the growing tools that epigraphists can use to aid their text restorations, we used these corpora specifically. They are the Packard Humanities Institute, the database of ancient Greek inscriptions, which I will refer to as PHI, Packard Humanities Institute. Then the Perseus Project, which is a digital library of Greek and Latin, but we focus just on the Greek one, literary texts. So your Homer is going to be there, your Aristophanes is going to be there. And then another repository is called First 1000 Years of Greek, which is by the Open Greek and Latin Project. However, as anyone will be able to tell you, a system is only as good as the data that it collects. So we didn't just need a lot of data, we needed a lot of clean data. And it became very obvious very early on, especially for the PHI corpus of digitized Greek inscriptions, there were a lot of noisy human annotations and often a lot of inconsistencies. To make this text machine readable, machine actionable for epigraphy restoration task, we had to do a lot of text cleanup. So what we did was we standardized the Greek alphabet to include all of the core characters. Then we introduced 2 special characters, which were the dash, which was flagging a missing character in the text. As I said, these inscriptions are damaged. And a question mark symbol, which flags a character which we want our model to predict. Then we ran a load of regexes to replace all of the inconsistencies, all of the human annotations, all of the non-ancient Greek texts, and all kinds of epigraphical specialized notations to indicate where a text is missing, where the human prediction is dubious, etc. And then we filtered the resulting text, so we only kept the restricted alphabetical characters. Then we discarded all of the text which had less than 100 characters, matched the number of missing characters with those which had been conjectured, suggested, hypothesized by the epigraphist with that special dash symbol. And the result of all of this cleaning was the PHIML training set, which is a corpus of over 40,000 inscriptions. We kept aside the valid and test and training data. We kept the testing data obviously distinct from the training data, and all of those put together amount to over 40,000 inscriptions, which have been clean. They have been made machine actionable. We open sourced all of this cleaned, the processing pipeline as well as the final result, because one of the sort of the recurring points of all of this work was to make all of these tools freely accessible by specialists or non-specialists, anyone who wanted to use these tools for their personal research or to satisfy their own curiosity.
Interesting. So 40,000 is a nice sized data set, but not a huge one when it comes to NLP. Did you guys think about using some transfer learning techniques or, I don't know, priming it with some other Greek, or maybe there's enough ancient Greek, I guess. What were your thoughts coming to the table in terms of the size of your data set?
Ancient Greek inscriptions, this is a small subset of what is available out there, but it is the parts that once we had cleaned the text, discarded the text with less than 100 characters, this was what we were left with. But with other ancient languages, for instance, Latin, we are dealing with unprocessed data, which on one of the main digital data sets, we're dealing with 1 million inscriptions. So a different scale of data availability. But even 1 million Latin inscriptions, I'm well aware, are nothing compared to current NLP projects, which might be dealing with the entirety of Wikipedia in all languages.
Right, right.
However, this data set which we obtained was the result of cleaning up just the PHI dataset, so the Packard Humanities Institute database of ancient Greek inscriptions. It was very much to our surprise, well, to my huge enthusiasm and to our general surprise, that when we realized, when we were doing ablation studies to check the predictive performance of Pythia on PHI ML, we realized that when we compared Pythia's performance to a standard language model, I'll tell you more about Pythia's architecture in a second, but when we compared it to a standard language model, which was working just at a character level, which had been trained, for instance, on the Perseus database of literary text. And then we set that language model to do epigraphical restorations. Its performance was much, much poorer than if we had just trained that simple language model on PHI, so on Greek inscriptions, the smaller corpus, and set it to the epigraphic restoration task. So it's almost as if the results are suggesting that the model can make a distinction between epigraphic and literary texts. As I said before, the inscription, the epigraphy, the inscription can be your sacred lore. It's something written on stone. So we're dealing with inscriptions which are texts of many, many different genres inscribed on stones, from your shopping list to your curse tablet to your ancient lore. Whereas with literary texts, we're talking about texts which have had a different tradition of transmission from the past to our days. You will imagine that there will be a difference if you're using a language model trained on Shakespeare to restore your shopping list. This is a stupid parallel, but if you're using Homer, the Odyssey, to restore a Greek sacred lore, you will have the same kind of thing will be happening. Again, it was a stupid example, but this divergence in performance for a simple language model was very, very interesting. And it's something which, speaking today, for instance, to a talk I was giving at the Oxford Epigraphy Workshop just an hour ago, that attracted a lot of the epigraphists' attention because we know that there is obviously a distinction between literary texts and epigraphical texts, and literary languages and epigraphical languages, let's say, languages in hyphens. But to see a result on paper from our ablation studies, that is very, very interesting.
I'm curious how you evaluate the performance of Pythia in terms of maybe, do you concern yourself with the same sort of diagnostics that a machine learning person would, like F1 score, or are you maybe just looking at the empirical results? And how do you find that Pythia stacks up?
To evaluate the difficulty of the epigraphic restoration task for a human, which any epigraphist can tell you, yes, it's very, very difficult and time consuming, but to actually evaluate it, we decided to call on 2 doctoral students who had prior expertise in epigraphy and epigraphical restoration. And we gave them a set of inscriptions to do as many restorations as they could on in a 2-hour time window. They performed quite well. They did an average of 50 restorations over those 2 hours. Their character error rate was of 57.3%. We have all of the ablation study results in the table in the published paper. That was our human baseline, which showed how really complicated this task is. We then set out to evaluate how our model would perform compared to a simple language model which works exclusively at a character level. This was where those differences between when the model had been trained on literary text and epigraphical text and set for the restoration task, how it performed differently depending on what training data it had been given. And then comes our model, which is working at both a character and a word level. And you can see that its character error rate is of 30.1%, which was a really, really good result. But what we had decided to do very early in the sort of designing stage of Pythia was to furnish epigraphists not just with an automated textual restoration tool, which provides the level of confidence for each hypothesis, but we also wanted to offer the epigraphist multiple predictions. That is why we used the beam search, and you can see that the top 20 column in that table shows in 73.5% of the cases, the correct restoration was the target sequence was indeed in that top 20 hypotheses of the beam.
As someone who follows the natural language processing literature, just a few years ago even, if you had asked me, should we try machine learning on a task like this, I would have probably said no. I didn't have the vision for it. But today, it'd be a very clear yes for me. I kind of know the state of the art. It seems like this is a promising thing to work on. Yet, a lot in NLP has been changing very quickly in the last few years. I don't know that other research areas know about that. What was your community's and your own perception going into this about the ability for machine learning to help a very specialized skill?
I come from an ancient history background, but I got into the field of digital humanities, which is basically using advanced technologies to aid, assist, extend the scope of the work of the humanities in general, and in this case, ancient history. What I am constantly shocked, well, positively struck by when I'm reading new NLP articles, or when this work was published in EMNLP, and we went to Hong Kong. One of my co-authors and I, just last month. Oh God, it seems ages ago. Time flies when you're finishing your thesis. Anyway, and there, just being able to listen to all of the new cutting edge state of the art applications, I couldn't help to wonder, oh, but you could use this for that, or just applying on a completely theoretical basis, because I'm still learning here. These the new advances in the field of ancient history specifically, because that is my main scope of study. But throughout this work, this research, this journey, the potential that the combination of machine learning and epigraphy, ancient history, the humanities in general, can have, impacting meaningfully the study of, in this case, inscribed textual cultures, but it could be dealing with visual data, helping archaeologists, for instance. There are some absolutely amazing projects out there which are dealing on tracking and restoring endangered archaeology of sites which have been sites or artifacts which have been destroyed either by natural disasters or by human action. And how topical this can be for the humanities is incredibly, incredibly inspiring for me. And I like to think of Pythia as an example of using machine learning to solve these more real-world problems.
How well do you think these techniques can generalize to some of those other languages? I wonder about something like Egyptian in particular, which is sort of a fundamentally different language in hieroglyphics from what I understand of more contemporary languages. Do you think there's opportunity? Obviously, there's opportunity for growth, but where do you think is the most promising to apply these techniques in the future?
My reply would be apply them everywhere. Extending the scope is of the a historian's work is just it's an incredibly exciting time to be doing ancient history, especially because we've now reached this availability of digitized data, which a few years ago was just not available. It was not possible to do such large scale research on the epigraphic cultures of the ancient world. Now, Egyptian is a very interesting case study. We're talking about a language, the specific variety of Middle Egyptian, for instance, which was used over a very, very long period of time. However, with Egyptian, you have a lot of problems relating, for instance, to having to convert into a digital format, so into a textual format, what are glyphs. You could, if you imagine ancient Egyptian, you will see the bird glyph, etc. That converting that into a machine actionable format is a hugely, hugely demanding task. However, when it then comes to, there are some digital databases of this available. But again, it comes down to availability of data. Your first reaction when I told you, oh, we have 40,000 Greek inscriptions, was like, okay, that's not a lot. And it is not a lot. To avoid just doing sort of statistical countings, and this is a problem which you have with a lot of data sets from the ancient world. And I think that in parallel with developing these research tools, such as Pythia, a lot of effort should be put into making even more material digitally available. Because it's not like it's not out there. As I said before, about 50 new inscriptions are discovered in Attica every year. That could be a text which can not necessarily change our understanding of ancient history's course, but it can provide so much more depth and detail, which is super important. And ensuring that all of this new material and all of the old material is consistently digitized and, above all, done so in a freely accessible way, open sourced and standardized and organized way. So, for instance, I'm thinking of what we did for PHIML, making it machine readable, standardized, actionable is super important. And there are loads of projects which are working on this. If I had to wish digital humanities and all of this field well-wish for the future, would be further collaboration. Everyone needs to be able to know who is working on digitizing what, because, for instance, and I myself am guilty of this. For my thesis, I created a digital database of the Sicilian curses, which I seem to keep on talking about, but I like using them as an example. A fun little data set.
Absolutely.
I digitized corpus of these texts, which had never been done before. And yet I am the only one with the password to this. I haven't open accessed anything. Also because I've kind of been sidetracked by creating an assistive tool for ancient Greek antiquity and finishing my thesis. But it's there. It's on my computer. Nice PHP, etc. Nobody can use that. And okay, I published the work, but that's not good enough. People need to access the raw data. And so on my to-do list, when I finish my thesis in December, the number one plan is to convert this text into Epidoc XML format and for it to be included in Jonathan Prague's iSicily digital database of Sicilian inscriptions. That is the way forward, making things standardized and accessible, especially freely accessible, is I think where the future should lie.
I think you hit on a key point there. The collaboration offers a lot of opportunity here. I couldn't imagine a machine learning person doing this project on their own, or I would imagine maybe you wouldn't do it on your own as well. It's a great team up, essentially. With that in mind, do you have any advice for how people on either side of the table or just with a discipline could connect with someone? I imagine you guys aren't in the same university buildings often.
No.
How would you propose people promote connecting in this way?
I was lucky because, as I said, I worked. I met Yanis at Wolfson College in Oxford. We attend the same college, and Jonathan Prague is my supervisor for my doctoral work. So this was how this team came to be. However, when I went to EMNLP just last month and sort of told people, I totally came out as an ancient historian. People were quite shocked, rightly so, but also they were interested, just as I was super interested in what their individual projects was. So it's not as if we have to overcome a huge kind of barrier or a gap or just the most basic obstacle, which is lack of interest. I mean, it's ancient Greek texts. How cool is that? Oh, it's NLP. That's also cool. It's, apart from the irony, we're not dealing with a lack of interest. I think what is important, especially, for both disciplines, is to overcome a kind of bias, which is often the has no basis, and just say, we know that you are working on this amazing stuff, or we know that you need these tools to develop this amazing stuff, and just use that as sort of a starting point for dialogue. We chose ancient Greek inscriptions because of personal interest, personal expertise, increased availability of digitized data, but also because the variability of its contents and context within this data set make it an excellent challenge for machine learning. So it's mutually beneficial. And thinking of just assistive tools sometimes is a little bit diminishes the incredible potential that enabling research on such a large scale, on such new and interesting data sets can have for both disciplines. My advice is, and this is coming from an Italian, so it's slightly biased, is just talk to people. Reach out to people. I reach out to a lot of people via email to just ask, to say, introduce myself. This is who I am. This is what I'm working on. Do you have any advice? Do you know about this, that, the other? And this is happening to me as well. After EMNLP, I've developed quite a lot of contacts with people who are interested in pursuing, in working on this kind of stuff from the NLP perspective, working into the Greek epigraphy or ancient Mediterranean written cultures perspective. And I don't blame them. For everyone here, the stakes are incredibly high. The yield is invaluable, and the fun aspect especially is just beyond this world. So talking to people to initiate these types of collaborations is key, even within your own field. Just thinking of a real world application and then asking for the expert's advice, the collaboration.
And I wanted to ask also, is Pythia a tool other people could use?
Pythia is freely accessible online. You can go to the GitHub repository and you will be there will be a link to the Colab Colab notebook where you can freely use Pythia for your own restorations, to visualize the examples which we discussed in our article, some other fun visualizations. This is all out there. It's all freely accessible. And the idea of making it all freely accessible is, in fact, to inspire future interdisciplinary work. Because of the careful design choices that we made when designing Pythia's architecture, we have created a model which can be used by all disciplines which deal with ancient texts. So codicology, papyrology, paleography, these are all super specialized disciplines which could benefit from an ancient text restoration model. And furthermore, the model can be applied to any language where you have enough data. So I am personally moving on to apply this work to Latin text restoration, which is the natural step forward, but I am getting people asking me, oh, can we use this for inscriptions with Semitic languages, or can be used by Sanskrit inscriptions? It can be used for Old English. Literally, you name it, it's out there. You need to get the data. It's there for the taking.
Well, to wrap up, what else is next for you? You've talked a little bit about some of your projects, but post-graduation and whatnot, what's your outlook for the future?
I'm at the final stages of my doctoral dissertation. So once that is handed in, then I'm going to have to wait a couple of months for the viva. And in this moment, I am applying for postdocs to bring forward that Latin text restoration project, as well as doing more sort of fine-grained work on the Pythia project, because Pythia has opened a whole new world of possibilities, of research directions. It is my desire to continue pursuing these directions, working, for instance, on topic modeling, on the geographical and chronological modeling of ancient Greek and Latin epigraphical texts, so that we can improve, first of all, the prediction process, because with ancient Greek, we're talking about texts which have been written, the PHI corpus contains texts which have been written over 1,000 years. So that's a lot of variability in language, in names, in grammar, in dialectal varieties. Plus, we also know how large the ancient Mediterranean world was. It goes from Spain to, at one point with Alexander, to India. So we're dealing with huge scope in both chronological and geographical terms, and being able to model those would be incredibly interesting to perhaps attribute new findings. For instance, if we found a new inscription tomorrow, which we did not know the original find spot for, we might be able to offer a place of origin based on this type of research, as well as a chronological attribution. And topic modeling could be very useful to sort of define what a very damaged inscription could be about. Is it a law? Is it a judicial text? Is it a curse? So this kind of refinement, which is super useful, I think, in the preservation of ancient culture, ancient material culture perspective, but it can also furnish new research foundations and new means to enable research on the epigraphic cultures of the ancient Mediterranean.
Well, exciting opportunities. I look forward to following this unroll.
Thank you. Me too.
Lastly, tell us where people can follow you online.
You can read about Pythia on the University of Oxford blog post, on DeepMind's blog post. You can read the article on the proceedings of ACL, and you can follow us on Twitter and on Academia, which is a page which is very big with humanities researchers, and see more work there.
I'll have links to all those things in the show notes. Thanks for taking the time to come on the show and share your work.
Thank you so much. I really, really enjoyed talking to you about this.